Question 12 is a typical calculation question for power rating, and the question is broken down to help you all solve the question also. So in part A, you are given the power rating and you are asked to find the resistance of the heating element. This is the same thing that I taught you all. Even without part A, the very first thing that you should do when you see a power rating is to determine the resistance using the V square over R equation. So rearrange the equation, make R the subject, and you can get 29 ohm as the resistance of the heating element. Now part B, when you connect this appliance, this kettle, to 240 volts in Singapore, what is the current flow? So we can easily just use Ohm's law to solve for this to get 8.3 amperes. Now, because the EMF applied to the kettle in part B is also 240 volt, just like what the power rating suggests, you can also use P equals to IV, where P equals to 2000 watts and the voltage being 240 volts. And from there, you can also determine the current using a different equation, but you get the same answer. Now in part C, what is the current if you now connect 120 volts power source to the kettle? Not 240 volts, but 120 volts of power source. So this is where the resistance that you found in part A comes in handy. And using Ohm's law, because you have determined the resistance of the kettle, this resistance value won't change whether you're in Singapore or in the States. So using Ohm's law, plug in a EMF value of 120 volts in the States. The resistance value from part A, 29 or 28.8 ohm. You can then determine the current passing through the kettle. And in part D, using this value of current, you can use P equals IV to determine the power of the kettle when it's used in United States. So you get 500 watts in part D. Again, notice that you cannot simply just use the power rating and just divide by 2 to get the answer to part D. You might be tempted to think that the power rating is 240 volt, and now if I apply 120 volt, isn't it half the voltage? If it's half the voltage, then can I just use the 2000 watts from the power rating, just halve it to get 1000 watt as the answer? As you can see from the answer in part D, that method or that shortcut method doesn't work.